Right, in this video, we're going to talk about 3.3 Objective 4, where we solve applications involving rules of differentiation. I've got a conversion table ready for one of these problems here in a minute. So that's what this is. And we have our calculator and our whiteboard ready to work out some of these application problems. So let's start with the distance an object travels due to acceleration, due to gravity, measured in feet, using acceleration in feet per second or feet per second squared. Here is what this formula is. D of t is equal to 16 t squared. Object is starting from rest, and we're calling its initial height off the ground 0. Again, we're just looking at distance. So d prime of t is going to be 32t. And the associated units of this derivative here will be feet per second. And it's going to be a speed or velocity. And then they tell us that it's going to take 8 seconds for the object to hit the ground. So we want to find d of 8 is 16 times 8 squared, or 16 times 64. And that's going to be 1024 feet high. And then they ask us for the speed of the stone in miles per hour, not feet per second, when the stone strikes the ground. So d prime of 8 is going to be 32 times 8. It's going to be 256, but this is feet per second. So I need to change this 256 feet per second to miles per hour. This is where this conversion table is going to come in. So we have 1 yard is 3 feet, and 1 mile is 1,760 yards. And that gets our distance that we want. And then there's 60 seconds in 1 minute, and 60 minutes in 1 hour. So we have 256 times 60 times 60 divided by 3 divided by 1760 is equal to 174.54 repeating miles per hour. Let's go back and look at our instructions. It says to round to the nearest integer as needed. So that's approximately 175 miles per hour. All right. City planners model the size of the city using the function a of t is equal to -1 over 40 t squared plus 2t plus 30. T has to be between 0 and 40. T is the number of years after 2010. So let's compute a prime of t. That'll be -1 over 20t plus 2. And this is only good for 0 to 40. And 1/20t plus 2. Units associated with this are square miles per year. Square miles per year. And it's the rate at which the city grows. So how fast will the city be growing when the city is 60 square miles? 60 is equal to -1/40 t squared plus 2t plus 30. 0 equals -1/40 t squared plus 2t minus 30. Let's multiply everything by -40. T squared minus 80t plus 1200 is going to be t minus 20 and t minus 60. T minus 20 equals 0, or t minus 60 equals 0. T is 60 is not within my domain. T equals 20 is. So let's just write that down. T equals 20. So now I want the rate at which it's growing. So clear. We want a prime of 20 is -1/20 times 20 plus 2. Is a -1 plus 2 is 1. And that's 1 square mile per year. Suppose the population density of the city remains constant from year to year at 1,000 people per square mile. Determine the rate of growth, population in 2050, which is when t will be 40. So let's look at the rate of growth for a prime of 40, which is going to be -1/20 times 40 plus 2 is -2 plus 2 is 0. So it doesn't matter how many people per square mile. The city's not growing at all, so the population's not going to grow at all either. Now we're talking about the growth of a cell culture that starts with 1,000 cells and grows according to the model P of t is equal to 1,000 plus 29 t to the 5th. P prime of t will be 29 times 5 is 145 t to the 4th. And we're given constraints that t stays between 0 and 4. What units are associated with the derivative, cells grown per day, and then the derivative measures the instantaneous rate of change of the number of cells grown at day t. All right. On the interval from 0 to 4, we were looking at this. It's a 4th degree polynomial. It grows quickly, but it would look something like this for this derivative function. So its lowest value is at 0 and its highest value is at 4 because it's always increasing on that interval. Let's look now here. These derivatives would just be the slopes of these lines. And we get rid of the or equal to's and the piecewise defined functions. So, oops, that last one is a greater than sign. And this is going to be the fish are growing in pounds per inch. right? And instantaneous rate of change of the number of pounds at inch X. So there we go. That's it for this video. We'll come back next time and we'll talk about 3.3 objective 5, where we simplify expressions involving product and quotients and find their derivatives. See you for the next video.